Today's video is brought to us by Alien Lego Man from the newer Space Police series. We're looking at section, lesson 4.1 on page 365. And the goal or the point of this section is to understand basic probability. So we're going to look at the key terminology. We're going to talk about these two types of probabilities that we calculate, theoretical and empirical, and just do some comparisons of that. So I think the first thing we want to understand is just when we talk about probability, what are we really meaning? And it is basically a number that represents how likely some event is to occur. It's the chance that something will happen. In the mathematical world, we get a little more specific about this. We want to talk about an event being something that is repeatable, that has well-defined outcomes, and we are then able to assign numbers to those well-defined outcomes. And we can calculate how likely something will happen based on the fact that we know these well-defined outcomes. An important thing to note is that when we talk about this number that represents the probability, it's a number between 0 and 1. So we can draw a little number line and say, these are all the possible values for a probability. And I'm getting a little bit ahead of myself, but I can't help it. When we associate the number 0 with a probability, we're saying it's impossible. And when we associate a number 1 with something, we're saying it's certain, which I struggled spelling it there, so just pretend I spelled that right. Man, I did it again. I think it's AIN, whatever. And we can represent these probabilities in multiple different ways. I've done these in decimal form, but we could also write these as percentages. So 0%, 50%, 100%. And you'll note later that we could also do this as fractions, 0 out of whatever number we want, 0 out of 100. We could say this is 1/2, or 50 out of 100 is also 1/2. Or let's see, 1 out of 1, anything that makes 1. So our author's like, hey, what do we mean when a forecaster says that there's a 70% chance of rain today? We're saying there's 70% chance that it's going to rain. I mean, like, I think that's kind of a funny question. It's saying it's more likely to rain than not rain. So this is the number associated with probability. And weather forecasters have come to this number. They're not just guessing at it. We know it based on a huge slew of data that we've collected over time, and we're able to predict weather fairly well based off of prior conditions. So, you know, how much moisture is in the air, what's the wind, the clouds, all that, which I know very little about. Okay, so let's get to it. The first thing that happens when we talk about probability is we define what's called a sample space. So, well, really, I'm getting ahead of myself again. We define what's called a probability experiment. This is that process I was talking about that leads to these well-defined results called outcomes. So, such things as flipping a coin, rolling dice, drawing cards from a deck of cards, predicting the weather. Is it going to rain or not going to rain? That's a well-defined outcome. It will either be raining or not be raining. And so this experiment, these outcomes that are a part of the experiment, is we can list all of them. And when we list all of them, we call that the sample space. And so what becomes important when we're trying to calculate a probability is to list all the possible outcomes in an experiment. So we already did that for the weather. If we're predicting rain or no rain, the sample space is rain, no rain, right? That is the sample space. And one way we do that is with the brackets. A couple examples down here, flipping a coin. I know he's worked them out here, but I'll write them here. We use these squiggly brackets, and you could get heads when you flip the coin, or you could get tails when you flip a coin. When you're rolling die, if it's a 6-sided die, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. Those are the only possible outcomes when rolling that die. If you roll a 20-sided die, right, it's 1 through 20. A true and false question, it's true or false. Flipping 2 coins is a little more interesting than 1 coin, because the first coin could be heads, the second coin could be heads. That's the result of the 2 flips. Or we could have heads first and then tails, or we could have tails first and then heads, or we could have tails and tails. Those are the 4 possible outcomes when flipping 2 coins. So these are the sample spaces, and from this we're like, hey, these are all the things that could happen, and we can start talking about probabilities that when we flip 2 coins, we get heads twice. All right, so let's try number 2. Write the sample space for the probability experiment of identifying a student's grade in a chemistry class or a chemistry course. Well, this depends on your school's grading system. At Jackson College, we use the 0.0 system to the 4.0 system. Some schools associate letter grades with this, would be like F to A or vice versa. So we'll do what your syllabus says about this course. You could get a 4.0, you could get a 3.5, you could get a 3.0, you could get a 2.5, and I'm doing it in order from highest grade to lowest grade, because that's typically what we want. So those are all the possible grade options for a student taking a course. And if I randomly assigned your grades in this class and it had nothing to do with the work you turned in, these would be the possible outcomes for that probability experiment. Of course, there would be anger, and you would be filing academic complaints against me if I randomly assigned your grades. And rightly so, right? Because you're putting in all this work, you're watching these videos, you're working through assignments, and you're learning the material and demonstrating that you understand this, and then I randomly assign your grade. How unfair might be the argument. Okay, so here's another one. Write all the outcomes of rolling 1 die that are odd. So this is not a sample space. This is examples of portions of a sample space, so parts of it. So when we think about the die that had 6 sides to it, the outcomes that are odd are 1, 3, and 5. And our author says this is an event. So an event is just simply a collection of 1 or more outcomes from a sample space. And this is where we start getting into the interesting world of maybe gambling, where we're like, hey, what's the chance I win if I bet on the die is being rolls an odd number? Now, our author gets a little bit crazy in the next bit, because he goes to the trouble to try to make a distinction between an event and an outcome. And it's super subtle. Like an outcome is just one thing, right? That's one key point. While an event can be one thing, or it can be multiple things. And really, I think the distinction between, are we identifying something as an outcome or are we identifying it as an event, is what we're doing with it, if it's just a single thing. So, like here, how many results match getting heads on the first flip and tails on the second flip when flipping 2 coins? Well, first, let me list all the outcomes. Let me list the sample space. Okay, there's 4 outcomes. There's our thing. So how many results match getting heads on the first flip and tails on the second? There's only one. It's this one. So author says that is an outcome. True, I agree with him. This is one of the outcomes in the sample space. But if I said, I want to calculate the probability of the event occurring heads first, tails second, then we could treat this as an event, and then distinguishing between it being an outcome and an event isn't that important. So I kind of disagree with how he's going about this. All right, question 5 says, how many results match getting one head and one tail? Well, there you can see there are 2. Here's one head, one tail, one head, one tail. So there are 2 outcomes in this scenario. That's definitely an event, because an outcome can only be one item. That's one of the other clear distinctions. Okay, number 6, we're going a little further. When rolling 2 dice, getting 3 on the first die and 5 on the second. There's only one way this can occur. It looks like this: 3, 5 on the die. This could be, that's definitely one outcome from a sample space of rolling 2 die. By the way, there are 36 outcomes when rolling 2 die together. Think of 1, 1 as one outcome, and then 1, 2, and then 1, 3, and 1, 4, and so on and so forth. So this could be an outcome. This could be both. When rolling 2 dice, getting a total of 10, well, there's multiple ways we could do this. We could roll a 4 and a 6, or a 6 and a 4. We could roll, let's see, what else gets us to 10? 7 and 3. No, you don't have a 7 on there. Is there anything else? What am I missing? 5 and 5. Yep, you could roll 2 5s, 5 and 5, etc. I'm not going to bother writing out more because we already know this can only be an event. This could be treated as both. And if we're flipping a coin 10 times consecutively, getting tails 8 times, this is, again, would be considered an event, because there are multiple ways we could get 8 tails. We could flip 8 tails in the first 8 flips. We could flip it in the last 8 flips. There's multiple combinations of ways this could happen.